Good morning, everyone. Wow, look at close. I don't have specific questions that I was planning on going over today. Today was meant to give you more information about the AP exam and just answer any questions you had from this week's assignment. So ideally, you have questions and have done something and so therefore have questions. And I will answer your questions. Wait a little longer. Wow, only 7 people this time. Well, hopefully some people will watch it later. As you hopefully have realized by now, we in every class the school is now taking like real grades, but daily grades. They're just daily grades, all weighted the same, one per week, as we already said, as I've mentioned. Just reminding you of this because there are a small few of you who have not turned anything in. So the assignments and work and place where you turn stuff in is on Google Classroom. I've been extremely lenient in how I grade it. I'm just looking to see if you did the majority of the assignment. I was the past 2 weeks. This week, lenient on how much, but I'll actually grade it comparatively to the key. But I mean, you have the key, so it shouldn't be hard to still get 100 this week. It's funny when we were told to submit 3rd grading period grades. At that point, we weren't doing any grades for 4th grading period. So thinking 4th grading period might not be worth much, if anything, I definitely helped some of you out with the 3rd grading period. And now 4th grading period is going to be worth 50% of the semester. So, I mean, if as long as you do work over the next few weeks and have been, some of you will probably really like your semester average after this. Okay, well, let's share screen. I want to first talk about, I just recently, like 30 minutes ago, posted a AP exam checklist, an AP exam checklist. This would be something to, at the very least, have downloaded and keep track of. Make sure you take care of these things. You'll be given your AP ID Monday that will work for all of the exams, and you'll get a specific e-ticket for each individual AP exam you take. Know when each exam is that you're taking. And this just goes through all the different things to make sure that you are ready to take the AP exam. Different things you want to make sure and have ready and available. You want to make, I mean, in a normal school year, the AP exam is held in the library, and teachers make sure that you are ready and make sure that you have all of the materials that you need, and you don't have that. So you have to make sure that you have all the materials that you need. Your computer and your phone ready for how you're you want to be ready on the day of the exam for exactly how you are going to do the exam. You're going to open it on your computer, which may be easiest to see the question. I think one of the easiest ways to do it would be to have it open on your computer, but handwrite your answers is what I think would be the easiest way. I mean, you're used to handwriting your answers, and most of you are not used to typing your math answers. The easiest way would be to handwrite your answers. You're allowed up to 5 pages per question, so just have 10 pages at the ready. As well as, if you're, it says it right here, if you're handwriting the exam, you want to have your pages ready. You need to have your APID, your name, and page number on each page that you handwrite your questions on. What other important information here? Let's do that. Yeah. Okay, once the exam started, you don't refresh the browser or do a back arrow. That would completely mess things up. It will give you the 5-minute warning of when you should start uploading your information. And so this is one other thing we should go over then. So on the same website, I keep telling you about each time, apcoronavirusupdates.collegeboard.org. If you go there, is that right there? Where do I have that? This tab, yeah. So if you go there, go to the For Students tab. It says you're a student. What is happening? Okay, then if you click on taking the exam. So I mentioned before that there will be a practice demo for you to practice how you would upload the exam and how the software and system will work, so you can practice that ahead of time. And they said it'd come out Monday, May 4th, but it's actually already available. So on this at this website, you then click the interactive demo. Then on the day of the exam, you would then type in your 8-digit APID, but for the next week, you could type in practice and actually practice how you would go about the exam process ahead of time, so that you understand how that will work. Then you can practice like doing the taking the picture, sending it to your computer, and uploading it, just so you know how long that process will take. So I would highly suggest doing the interactive demo ahead of time. That would be necessary for preparation. This is very different. You don't want to be thrown off by the timing or how the system works during the exam. You want to know how that will work ahead of time. Okay. Well, I would again suggest keep in mind all of those materials and all the information about the exam. Practice the demo ahead of time. Let's go over, do you have any questions from the MasterMathMentor FRQs? Any questions you want me to go over from the MasterMathMentor FRQs? Okay, A2 Part C. Okay, let's do it. A2 Part C. So share my screen. So let's go here and then so in part C, they are asking for a point of inflection. They're asking for a point of inflection. So where in the interval from -2 to 2 is there a point of inflection?
Mr. Hunter, I think Chris said part B.
Part B? Oh, part B, okay. Part B then. Okay, well, part B, average rate of change of G on the interval from 0 to 6. Well, average rate of change is just slope. Average rate of change is slope. So we want the average rate of change of G on the interval from 0 to 6. That would be G of 6 minus G of 0 all over 6 minus 0. Just slope over the interval. That's the average rate of change. Well, G is not a normal function. G is a integral function. It's an area function. We need to figure out what G of 6 is and G of 0 is. G of 6 would be the integral from -1 to 6 of f of t dt. Well, the integral from -1 to 6, this triangle here from -1 to 0, that area is going to be a -3. We want to go all the way to 6. That triangle there, 1, 2, that'll be 3. That'll be an area of 4. This will be an area of 1. Yeah. And then from 5 to 6 will be -0.5. Okay, so we have 5 minus 3.5. 5 minus 3, right? Yeah. Well, 5 minus 3, that's 2. Minus 0.5, so 1.5. Good, 1.5 there. And we also need G of 0. G of 0 would mean the integral from -1 to 0 of f of t dt. Integral from -1 to 0 is -3. Now we can just plug that in to average rate of change. So 1.5 minus 3, no, minus a -3 over 6. Well, minus a negative, that's really plus. We have 1.5 plus 3 divided by 6, which is 4.5 over 6. And 4.5 over 6, that also simplifies to 3/4. Right, yeah. With that. Okay, any other questions? Do I need to do more of A2 or more or any of the other ones? Part E on the same problem, A2. Okay. Make that super small again. Okay. So in part E, change colors to blue. Part E on A2, we're asked to define, well, no, not asked to define, we are told, can you breathe here now? We're told h of x is going to be x g of x, and we're asked to determine if there's a relative min or relative max, or neither, for h at x equals 2. Okay, well, at relative min or max, those occur when the derivative equals 0. Those occur when the derivative equals 0. So we first need to figure out if that is happening. I figure out if the derivative does equal 0 at that point. Because if it doesn't, then it's automatically neither. So if we want the derivative, we need to first take the derivative of this function. So we're going to have h prime of x equals, okay, we've got to do product rule here. Derivative of x is 1 times the other function as is, so that'll just be g of x plus x times the derivative of the second function, g prime. Okay, so that is the first derivative. Now let's plug 2 in to see if we have the derivative equals 0, if there is a horizontal tangent there. So h prime of 2 that would be g of 2 plus 2 times g prime of 2. Okay, well, g of 2 means the integral from -1 to 2. Integral from -1 to 2. Okay. Integral from -1 to 2 of f. Well, from -1 to 0 is -3. And then if we go to 2, from 0 to 2 is a +1 unit. So -3 and 1, that's -2. G prime of 2. G prime of 2, that, well, if we take the derivative of the integral, g prime of x will equal f of x. So that means g prime of 2 is just f of 2, and f of 2 is 1. F of 2 is 1. So that means we have a -2 plus 2 times 1, which is 0. So the first derivative is 0 at x equals 2, so it could have a relative min or max. Now we just need to figure out which one it is. Which one it is. And to do that, we don't have a graph to be able to analyze. We don't have a normal function to be able to figure out whether the derivative is positive or negative on either side, or that would be a lot more work. So we're simply going to do the second derivative. We're going to do the second derivative test by taking the second derivative and figuring out whether the second derivative is positive or negative at this point. Because if the second derivative is positive at 2, then it is concave up, and so it would be a minimum. If the second derivative is negative at 2, the concave down, and so a maximum. So now h double prime of x. Okay, so derivative of g is g prime of x plus, now we have derivative of x g prime. Well, got to product rule that. Derivative of x is 1, then times g prime. We have a g prime there. then plus x times root of g prime, which is g double prime. Okay, and with that in mind, let's write down what would g double prime represent. G double prime of x is f prime of x. Okay, we now need to figure out what is h double prime of 2. H double prime of 2. Okay, we're going to plug 2 into that. That would mean g prime of 2 plus g prime of 2 plus 2 g double prime of 2. Okay, well, g prime of 2, we already found was 1. We already found g prime of 2 is 1, because that's just f of 2. So we have 1 plus 1 plus 2 times. Now we need g double prime of 2. Well, g double prime of 2 would mean f prime of 2. F prime of 2, well, that would mean the slope of f when x is 2. The slope of f when x is 2. And the slope of f when x is 2, that's just a positive 1/2 slope. 2 times 1/2, that's 1 plus 1 plus 1, that is 3. Okay, well, that means g double prime of 2 is positive. So concave up. And if it's concave up, we must have a minimum at x equals 2. Therefore, relative min at x 2. Okay. Any other questions you want me to go over? Hayden, what questions are due for homework this week? So, to make it a little easier and just less, because I don't know what you're dealing with right now. Ideally, for preparation, you're able to do all of it, but I don't know what you're dealing with. I decided for this week, all that is due is just 2 of the MasterMathMentor FRQs. You could just take a picture of doing 2 of them, and that would be fine. Or if you take a picture of doing more than 2, I will just grade the best 2. But just 2 of the MasterMathMentor FRQs. There's 5 in that file, just 2 of them. And I'll grade them based on accuracy, but you have the key, so that shouldn't be hard to be accurate. You are taking the AP exam, which should be, pretty sure it's all of y'all. Everyone who's here is taking it, because it is past the cancellation time. Okay, Chris asked for A4 parts B and D. If you are taking it, you should try to do more than just the minimum of what's required. But the minimum is just 2 of the MasterMathMentor ones. A4 parts B and D. Okay. Clear that real quick. That's weird. Don't know where that came from. Okay, we can delete that too. A4 parts B and D. Okay. I like A4. Part A should be relatively easy on A4. So, A4 part B. We're asked to show that any point with initial condition that is along the y-axis. Well, along the y-axis, well, that means that the y value is whatever, but the x value is 0. So they're saying if we have an initial condition along the y-axis, meaning if we have an initial condition of a point 0, comma, anything, or just y is positive, where we have a positive, put up a positive sign, that's going to create a relative maximum for the particular solution. That's going to create a relative maximum. At any point with initial condition along the y-axis where y is positive, that creates a relative max for the particular solution. Yeah, so that's what that's asking. We're asked to show that that will happen. Okay, well, first off, for it to be a relative max, then that would mean that, instead of using the letter y, I'm going to use some other letter just so it doesn't get confused with the y already in the expression. Oh. Okay, so if we have initial condition 0, comma, we'll go with k, 0, comma k, where k is positive. That's going to create a relative max there. Okay, well, if it's relative max, then that means that the derivative is 0 at that point. So let's first just make sure that's happening. So we would need to show that that's happening. So dy dx at the point 0, k, that would be -2 times 0 times k minus 1. Okay, well, that is 0. Okay, so the first derivative is 0 there. So could be a relative max. Well, now let's find the particular solution using that point. Just to answer the question, to show that it would be a relative max. Oh, wait, no, we don't even need to do that. We want to show it's a relative max, so it's kind of like the last problem we just did. Because to have a relative maximum, the derivative, first derivative would have to be 0 to have a horizontal tangent. And then the second derivative, if we have a maximum, so we have a horizontal tangent at the maximum, and the second derivative at the maximum would be negative because it'd be concave down there. So we just need to show that the second derivative is negative. So let's take the second derivative. So we're taking the derivative of the derivative. Okay, we got to do product rule here. So derivative of -2x is our first function, y minus 1 is the second. And chain rule will also have to be involved. This is essentially implicit differentiation. So derivative of -2x is -2. Then times the second function as is, y minus 1. Then plus a -2x times the derivative of the second function. Well, the derivative of y minus 1, derivative of y, well, would be 1, but then times the derivative of y, which is dy dx. Times dy dx. And so let's be a little more specific with that. We have -2 times y minus 1 minus 2x. And then instead of dy dx, we're going to put what dy dx is. -2x y 1. Now we're just going to plug in our point. So when we plug in our point into that, I'm going to write it over here. D squared y dx squared at the point 0, k. Okay, at the point 0, k, we would have negative 2 times k minus 1. And remember, k is positive. Well, not just positive. K is more than 1. K is more than 1. Yeah. Now I'm going to go ahead and distribute this. That negative 2x times that negative 2x. So I have plus 4x squared. Wait, no, that'd be plus 4 0 squared. That'd be 0. 4 times 0 squared times k minus 1. Okay, meaning this whole term over here is 0. K minus 1, that is positive, times a negative 2, meaning this second derivative is negative. Because you got that negative 2 times that positive k minus 1, because number bigger than 1 minus 1 is positive. So the second derivative at that point is negative. So if the first derivative at the point is 0 and the second derivative at the point is negative, it must therefore be concave down. Concave down at 0, k. So relative max. There. Okay, so that's part B. Then for part D, we're asked for the solution in part C, find the limit as x equals 0 of fx over tangent of x squared. Oh, okay. Well, the only way we can do that is we need to find part C then. So I guess I'll show part C too. I'll show part C. Okay. Well then, to show part C. Well, in part C, we're asked to find the particular solution y equals f of x with the initial condition f of 0 equals 0. Well, when we find the particular solution, the first step would always be to separate our variables. So we'll move stuff dealing with y's over to the left side, stuff dealing with x's over to the right side. Where on right? Put it over here. So that would give us 1 over y minus 1 dy equals negative 2x dx. Then we'd integrate. Integral of 1 over y minus 1 with the natural log of the absolute value of y minus 1 equals integral of a negative 2x would be a negative x squared plus c. Okay, now we're going to plug our point in. F of 0 equals 0. If we plug that point in, that means we have natural log of absolute value of negative 1 equals 0 plus c. Well, absolute value of negative 1 is a positive 1, and natural log of 1 is 0, so just c equals 0. Okay, that's nice and easy. So we just take care of that. That now gives us, that just is 0. So now we just want to solve natural log of y minus 1 equals negative x squared. Solve that for y. So we'll e both sides, making it y minus 1 equals e to the negative x squared. And then we'll just add 1, so y equals e to the negative x squared plus 1. Okay, so that was part C. That was part C. So that's our particular solution on part C. Now we can do the part D that you asked about. I'll continue with part. I'm going to erase some of this down here in my way. Okay, in part D, we're asked to find the limit as x approaches infinity, no, not infinity, 0, of f of x. Wait. Why? Of f of x over tangent x squared. Did I mess up in part C?
That's what I got. That's why I was confused, because it gives me 1 over 0.
I would have assumed that would have been a
2
low.
over 0, I mean.
Yeah, that would give 2 over 0. And I thought this would be a L'Hopital problem. I'm going to check what they did real quick. This was question 4. Part. Question 4C. But they got y minus 1 equals c e to the negative.
So then the x would go to 0, and then e would equal, e to the 0 would be 1.
No, that shouldn't have changed anything though. Y minus 1. Okay, well, I'll do it the way they did then, because that does make more sense. Not sure why my way didn't work though. Okay, well, one reason why they got a different number was they plugged in for C after eing both sides. So like we have a C here. They e'd both sides, which would then give y minus 1 equals c e to the negative x squared. Then they plugged in the 0, 0, which would give negative 1 equals c e to the 0. So c must be negative 1. So then if c is negative 1, yeah, we would then have y equals negative e to the negative x squared plus 1. Yeah, that's the difference. Okay. Because now, if we do take the limit as x approaches 0 of f of x over tangent of x squared, well, the limit as x approaches 0 of f of x does equal 0, because e to the 0 is 1 times negative 1 plus 1, so that would be 0, and then the limit as x approaches 0 of tangent x squared would also be 0. So then we use L'Hopital's rule. Erase some more of this. Give myself room. Then the limit as x approaches 0 of f of x over tangent x squared will equal limit as x approaches 0 of f prime of x over, okay, I gotta take the derivative of tangent. That'll be secant squared of x squared times 2x. Secant squared of x squared times 2x. Derivative of tangent is secant squared. That multiplies by, okay, yeah. Okay, then the derivative of the top. What is f prime? Prime of x. Well, that whole thing would just be a negative e to the negative x squared, but then times the derivative of the power, which is negative 2x. So that would give a positive 2x e to the negative x squared. Oh, the 2x's will end up canceling. So this is just the limit as x approaches 0 of e to the negative x e to the negative x squared over secant squared x squared. Okay, and now we want to plug it 0 into that. Well, that's secant squared of 0 on the bottom. Well, secant is just 1 over cosine. And so it's 1 over cosine squared of 0. Cosine of 0 is 1. And so the denominator is just 1. And then the top, e to the negative 0. Well, e to anything to the 0 power would be. Top is 1. So the answer to D is 1. Which, what do they got to? Okay, any other questions? Well, there is only 5 of us. If there's more, I'd say to do the Kahoot, but there's only 5 of us, so that would be boring, especially since I'm one of the 5. Well, hope you'll have a great day. I do miss you. Please know that. I wish this wasn't happening.
Bye, Mr. Hunter.